This is a video on partial fractions. The question is to integrate 5x squared minus 11 divided by the quantity x minus 2 times the quantity x plus 1 squared dx. What makes this challenging is that one of the factors in the denominator is squared. So for the partial fraction decomposition, we first have the x minus 2 factor, so I have an a over x minus 2. Now the x plus 1 factor is squared, and when I have a square of a factor, I put a constant, in this case b, over the factor x plus 1, and then plus another constant, in this case c, over the factor squared, x plus 1 squared. And now I could proceed as usual.
I put this over a common denominator.
And then set the numerators equal to each other. So notice that for the first term, I'm going to have to multiply by x plus 1 squared. The second, I have to multiply top and bottom by x minus 2 times x plus 1. And for the third, I'm going to multiply by x minus 2. So what I get is a times x plus 1 squared plus b times x minus 2 times x plus 1 plus c times x minus 2 is equal to, and then I set that equal to the left-hand side's numerator, 5x squared minus 11. Now let's set x equal to negative 1, and that zeroes out the first term, and it zeroes out the second term. So what I end up with is x minus 2 becomes negative 1 minus 2, or negative 3c. And when I plug in negative 1, 5 times negative 1 squared minus 11 is negative 6. Now just divide by negative 3, and I get c is equal to 2. The next step is to set x equal to 2 to zero out the last two terms. And when I do that, 2 plus 1 is 3. 3 squared is 9. I get 9a. This term is gone. The third term is gone. If x is 2, 2 squared is 4. Times 5 is 20. Minus 11 is 9. So 9a equals 9. Divide by 9, and I get a equals 1. Now let's work on finding b. And to do that, I'm going to plug in what I got for a and c. A is 1, c is 2. So I plug in, and I get x plus 1 squared. That's my 1 times x plus 1 squared. I still have b, x minus 2 times x plus 1. C is 2, so I get 2 times x minus 2, and I still have 5x squared minus 11. The next step, and I did a lot of work, and I'm just going to show you the next line. What I did is I FOILed this first term out, I FOILed the second term out, I multiplied the third term out, and then combined like terms. And what I got was b plus 1 times x squared plus a negative b plus 4 times x plus a negative 2b minus 3 is 5x squared minus 11. So notice in particular for the x squared coefficient is b plus 1 on this side, it's 5 on this side. So if I set b equal to 4, then I'll get 5x squared. And note, by the way, at b equals 4, I get 0x, and I get minus 11, like I expect to get. So b equals 4. Now I'm ready to put my constants into the partial fraction expansion and then integrate. And I get the integral of 1 over x minus 2 dx plus 4 times the integral of 1 over x plus 1. That's because b was 4. Plus 2, there's my c, times the integral of 1 over x plus 1 quantity squared. And I can integrate all three of these. For the third one, I'm going to set u equal x plus 1, and then du equals dx. And the first two integrals, this is just a log. Notice if du is x minus 2, du is dx. And if u is x plus 1, du is dx also. So the constants don't change. And I just get natural log of x minus 2 in absolutes, plus 4 times the natural log of the absolute value of x plus 1. And then I have plus 2 times the integral. This becomes a u squared in the denominator, or u to the negative 2 du. And the integral of u to the negative 2 is negative u to the negative 1, or negative 1 over u. So my final answer is here's my natural log of the absolute value of x minus 2. Here's my 4 times the natural log of the absolute value of x plus 1. And then I have my minus 2 over u was x plus 1, plus a constant, and I'm done with the problem.